Welcome to Software Minimalist channel. My name is Piotr, and today I will explain once and for all what is the main difference between object-oriented programming and functional programming. I recently commented with the answer on one of Dave Farley's videos. Here it goes. First of all, I find it amusing how terrified programmers are of stating their professional opinions on this subject. The cultural domination of by-reference languages really is significant. And this is the point in a nutshell already. Not object-oriented languages, by-reference languages. It is my opinion that functional programming is not only a little better than by-reference object orientation, but much better. I believe it's the only direction for software engineering to evolve. By-reference languages will not take us where we need to go. And it has nothing to do with modeling reality, objects with data inside, inheritance of types and their properties, association of data and functions, etc. Because even functional languages support these features. For example, Clojure, with its protocol implementations, gives you object-oriented interface behavior. It's all about object mutation and memory manipulation, and lack of control over it. One more time, because that really is the essence. It's all about by-reference mutation of memory happening at a distance and lack of control over it. For example, when we have a class inheriting from another class, which is composed of multiple classes with more of the same for a couple of layers, and then we call a method to mutate an object instance, a deeply nested object. What data changed and where and how? Nobody knows. To understand it, you would need to unpack the whole thing, not only at edit time, but at runtime. Now try to parallelize it. Race condition. By-reference passing of objects is the trillion-dollar disaster of software industry. It is a byproduct of the limited resources of early computers, where designers had to and did invent clever ways to manage memory in place. And it has led to this unfortunate local optimum we are now trying to get out of for the past 30 plus years. It was not recognized back then when we were going into a blind alley, when the amount of memory was our biggest problem, and nobody dreamed of networking thousands or hundreds of thousands of machines with parallel processors. But our priorities changed, and our by-reference languages didn't. What's really funny is that it's universally recognized in software engineering community that global variables are a bad idea. They lead to race conditions, they reduce readability, they couple disconnected parts of code, they make state unpredictable, and so on and so on. Just a very bad idea. Some would say never use global variables, and I would agree. But some of the same people, maybe even in the same sentence, will recommend passing an object by reference, not realizing they have just recommended a glorified global variable. It's not only that by-reference objects are the same problem as global variables, they are even worse because they have an additional obfuscating structure on top. Once you share a reference to an object, you have no control over it. And you have no idea who and when will invoke a method on your object. And methods in OOP are modifying internal state of an object directly. So you gave away the control of the state completely while pretending this is encapsulation. Java, C++, C#, Python, all languages passing objects by reference and allowing the spooky action at a distance are guilty. Even Alan Kay, who originally coined the term objects, doesn't agree with modern OOP. For him, the idea of objects always was to mimic the behavior of biological cells or computers in a network. Objects were supposed to be truly encapsulated entities communicating with by-value messages similar to modern understanding of microservices. They could decide what they wanted to do with the messages. Messages were requests, not commands. They had complete autonomy. Unfortunately, the term object-oriented was hijacked by the by-reference crowd and evolved to only mean the splitting up of global variables into controlled and modular, less than global variables. It's obvious that this was not going far enough as an improvement over imperative programming The moment you realize C, which is not an object-oriented language, could do all the same things as C++, which is an object-oriented language, and it seems C++ was just syntax sugar on top of C, and global variables remained a problem, as they always were, just with a new name. The functional programming way of solving the induced exponential complexity of the mutation problem, by controlling the flow of data and using immutability, that is the killer feature. To understand the flow of data from inputs through compositions of pure functions to outputs. This allows, for example, for all bugs to manifest locally and be fixed locally, no matter the size and complexity of the project, allowing for pure functions-based testability, making tests repeatable and reliable, facilitating easy refactoring, making software designs truly simple as intended by agile pioneers. While functional programming feels like building something from Lego blocks, by reference OP feels like you spend more time doing detective work, trying to fix the problems induced by the language idioms, rather than moving your project forward. Besides data flow, it's great having functions as first-class citizens of the language, not needing to memorize all object-oriented patterns and solid principles, because polymorphic behavior is solved by passing functions around. That's much simpler. Everything you do to achieve polymorphism in object-oriented languages, you do in FP by passing functions as inputs to other functions, creating functions on demand, returning them from other functions, or all of the above at once. The moment you understand both FP and OOP, you will notice that solid principles are designed to move OOP closer to functional programming, to make it more like functional programming, unfortunately with extra boilerplate code. Just look at the examples of lambdas and higher order functions being added to all by-reference languages now. They try to keep up somehow. Frameworks like React.js, Google's Dataflow, AWS Lambdas, growing popularity of languages like Haskell and Clojure, and their actor-oriented cousins, Erlang and Elixir. To my comment, I received a reply which really resonated with me. Here it is. I program C++ for microcontrollers with limited resources and use Elixir for networking applications. I strongly agree with the above opinion. Passing by reference in C++ is just a trick to save memory resources, and it causes countless painful consequences. The C++ or object-oriented programmer in general often consoles themselves that it's okay to pass by reference. It's good to be able to continue his work, or else he'll have nightmares thinking about the unexpected cases in the code they wrote. Also, in other popular OOP languages such as Python and JavaScript, programmers pretend that the object reference they have passed is the value itself, which is okay in many cases, but if it's not okay, it's going to be a catastrophe. Sometimes they aren't even aware of the difference themselves. One more comment by another YouTuber: functional programming makes state management explicit. OO makes it complicated. By the way, this is also the killer feature of Rust programming language. The fact that memory manipulation by the means of spaghetti mess is not allowed, but instead data flow must be understood and followed. The designer must understand which variable will be used where and correctly define the copying and modifications of said variable for two functions not to conflict with each other. The mechanism ensuring that data flow is not violated is called the borrow checker in Rust. Borrow because functions are borrowing the ownership of the variables and they have to give it back. It's quite verbose, but it works really well. So well, in fact, that people are already rewriting parts of Linux kernel into Rust. It's both disappointing and exciting that it took so many years for functional programming to gain traction. It's disappointing because we have a lot of inertia to undo. It's exciting because the industry starts to recognize the superiority of functional approach, with data flow-driven functional development becoming the new and better way to design complex systems. It's not really new, but it is better. Thank you all for joining me today. Please like, subscribe, and share. Provide super thanks or Patreon support if you can. and have a beautiful day. Until next time, your software minimalist.